Hello there, welcome to the Learning of Engineering tutorials. In this video lecture, we are trying to learn elongation of a bar due to its own weight. In most of the time, in engineering construction, the self-weight of the component is going to be neglected. And only the payload we are going to be considering, and we are designing the structure of the system. It's maybe a mechanical system or maybe a civil structure or electrical system. But in this case, we need to find if suppose the own weight is self-weight is there, then how it is going to be elongating. Suppose you can take a semi-solid materials and you can take it in your hands. There we can see how that semi-solid materials is going to be flowing. That's because of the gravitational force. So, but the same thing is if you take in the solid materials, they are well packed material, and that level of elongation may not be there at the micro or nanometer level. Elongation is going to be there. Now we are trying to see how it is going to be. There we can see I have taken a bar. The cross section we can assume either circular or rectangle, right? And A end is going to be the fixed and B end is the free end is there. And the total length of the bar is the L. And other parameters we can see the area A is going to be cross sectional area, L is the length of the member, and E is going to be Young's modulus of the system. And we need to find out the load, how much it is going to be acting. So then we can take in here is the specific weight of the system. Then how could you define the specific weight of the system? We know the specific weight of that bar is equal to the self weight of the system, that's going to be W divided by the volume, unit volume of the system, or the volume of the system we are going to be taking. So from this one, I am going to be modifying self weight of the system is equal to, because the specific weight is going to be the constant one. So here W, this is the specific weight into the volume, and further simplification, this I am going to be taking here W is equal to area into length. I can use at any form of the equation for the development to find out what is exactly the self weight of the system, right? So if you want to find out the elongation of this member, that means we need to find out the del L of this member. So then how could you calculate here? So then in this case I am going to be considering the elemental strip. So there we can see at certain distance from the free end I have taken one elemental strip, that is going to be the x distance I have to consider, and the length of this elemental strip is going to be the dx I am going to be considering. So can you see from the free end I have considered one elemental strip, that is the x distance I have taken. Similarly the length or the thickness of that material I am going to be saying the del x I have to consider here. So then how could you find out here? So then we need to find out the specific weight of this system or weight of this member we need to be considered. So here we have taken the total self weight of the system we have taken, but now we need to find out the self weight, because the elongation of this elemental strip, that is because of the L length of the material, right? So that how could I am going to be taking here? So can you see that I am going to be taking the Px load is going to be acting from here. Suppose this is the Px load is going to be acting. The Px is equal to, how should you write over here? So that means the load is equal to the specific weight into, that's the area, that's going to be the Ax, and the length is going to be the Lx, that means the x distance it is going to be there. So there we can see, so that means the load acting on the elemental strip is equal to the self weight of the system, that is going to be specific weight of the system, the cross section area, and the distance from the free end we have taken. So now once I am going to be calculating the load acting on that elemental strip, then I can take it over here, the stress induced in the elemental strip. The stress induced in the elemental strip is equal to the load acting on the elemental strip, the cross-sectional area of the elemental strip. So then how we are going to be writing this? I am going to be writing specific weight and cross-section area into x, we do have Ax is there. So in this case cross-section is going to be cancelled out. Then finally I am going to be getting here sigma x is equal to, that is the stress induced in that material is equal to specific weight into the x, I got it. So once I am going to be calculating the sigma x, then I want to go with find out the strain in that material. So we need to find out the strain in that elemental strip. So that I am going to be taking the strain is equal to epsilon, suppose. So then how could you write it? We know the Young's modulus is equal to stress by strain we are getting. Now I am going to be taking here is the strain. So that I am going to be writing the strain is equal to sigma x by E, I can take it. The sigma x is going to be right. I am writing sigma x, by E I am going to be writing. That is the strain is equal to specific weight into the distance, that is the length is going to. So this is going to be the strain is acting. Now I am going to be writing the strain in terms of the dimensional parameters. The strain is equal to del L by L I am going to be taking. But now we are going to be taking only for the elemental strip length we have to be take it. So how we are going to be taking over here? So now I am writing, so del L we need to be calculate. So that I am going to be taking here del Lx, that is the elemental strip elongation we are taking. The strain Lx into L is going to be the length of the elemental strip, that is going to be dx we are getting. So that is your length of the element. So that I am going to be substituting specific weight into the distance divided by E and into the dx we are getting. We know, so this is only for the elemental strip. Suppose if we want the same equation for the total elongation, so that how we are going to be taking. So I am going to be taking the integration of that system. So we are taking the integration, that is the 0 to del L, and this is going to be 0 to L we are going to be considering. So from this one I am going to be getting the total elongation of this bar due to the self weight is equal to, this is going to be the constant parameters, integration 0 to L, x dx is going to be your x squared by 2, 0 to L we are getting. Further simplification, del L is equal to specific weight by E and L squared by 2 we are getting. And further simplification, what I am going to routing, specific weight into length of the member divided by 2E I am going to be considering. We know the the specific weight into the length of the member I am going to be taking del L is equal to the self weight of the system into L by 2E I am going to be taking. So this is the way we are going to be calculating the elongation of this member due to the self weight. That is the del L we got it, right? That is going to be self weight into length of the member divided by 2 into Young's modulus. So initially we have taken one elemental strip that is located at a distance of x, and the length of the elemental strip is going to be the dx. First we need to calculate the load acting on this member, that is the Px we have calculated. Once the Px is calculated, then I have calculated the sigma x. Once the sigma x is over, then the strain I have calculated. Then strain I have substituted in terms of your dimensional parameter, and then I did the integration. So I substituted the limits value, and then finally I got it the elongation, and due to the self weight is this numerical method. If in this case you can substitute the WL and the E values, so then finally we can calculate the parameters. So I hope you are able to understand how to develop the mathematical model for a member which is going to be subjected to the self weight of the system. Most of the engineering structures we are going to be not considering the self weight of the system because it can self-sustain. So still, if you feel any difficulty or a confusion on this topic, please put in the comment section so that I can reach you out. Thank you.